In this video, we'll write the balanced net ionic equation for K2CO3 plus PbNO3 This is potassium carbonate plus lead 2 nitrate. So first thing we need to do for our net ionic equation, balance the molecular equation. You can see I have one potassium here and two here. So I'm going to put a 2 as my coefficient. That balances potassiums, but I have two nitrates. That's okay because I have two nitrates here. Those are balanced. Lead, and then I have a carbonate here and here. So the molecular equation is balanced. Now I can write the state for each substance. Potassium compounds, very soluble. I'm going to put an AQ after that. Nitrates are very soluble. And again, we have another nitrate. So these are going to dissolve, dissociate into their ions. But lead carbonate, let's take a look. Carbonates are often insoluble. So our carbonates here, these are our carbonates, and here's lead. So as we go over, and here's the carbonate. So we go up, and you can see insoluble. In fact, most of the carbonates are insoluble except for those group 1 elements and the ammonium compound. So lead 2 carbonate, I, that means it's insoluble. It's not going to dissolve, so it's going to be a solid. So we'll write S after the lead 2 carbonate. In fact, it's going to fall to the bottom of the test tube when these two react in a precipitation reaction. So we have our states. Now we can split the strong electrolytes into their ions for the complete ionic equation. So potassium group 1 on the periodic table, so it has a 1 plus charge. Carbonate, the whole thing, 2 minus. Good one to remember. So we have 2 of these potassium ions. I'll write the states later. I won't write that now. And then we have the carbonate ion, that's CO3, 2 minus. For the lead 2 nitrate, lead, that's a transition metal. We don't know the charge. We have to look at what it's bonded to figure that out. But the whole nitrate ion has a 1 minus ionic charge. Since we have 2 of them, lead has to be 2 plus. So the lead 2 ion, we write that, and then we have 2 of these nitrate ions. And these are the reactants in our net ionic equation. For the products, we said plus and minus. 2 potassium ions again, plus 2 nitrate ions. And then for the lead carbonate, lead 2 carbonate, it's a solid. So we don't split solids apart in net ionic equation. So this stays together. This is what we call the complete or total ionic equation. Now we can cross out spectator ions. They're on both sides. They really haven't changed, so we're not interested in them. Let's see what we have. In our reactants here, we have 2 potassium ions, and in our products, we have 2 potassium ions. We have 2 nitrate ions in the reactants and in the products. Get rid of those. Everything else is unique. So that's the net ionic equation for K2CO3 plus PbNO3 I'll clean this up and write the states. We'll have our net ionic equation. So this is the balanced net ionic equation for potassium carbonate plus lead 2 nitrate. You'll notice charge is conserved. We have 2 minus and 2 plus, so that gives us a net charge of 0. We have a net charge of 0 over here. It's a neutral compound. And if you count the atoms up, they're balanced as well. Sometimes you'll see the positive ion written first. Doesn't really matter. It's the same equation. Maybe it looks a little nicer. But this is the balanced net ionic equation for potassium carbonate plus lead 2 nitrate. And this is Dr. B. Thanks for watching.